In this lecture, finally we will conclude the introduction module with the remaining topic challenges associated with the wireless networks. Already we have covered the evolution from the pre-industrial ages till now, specifically pertaining to cellular evolution. We have discussed all the generations. We have also discussed about the electromagnetic spectrums and spectrum regulation, both with respect to India as well as the global spectrum allocation and the agencies involved. Now today we'll start with the challenges and finally conclude the introductory part. So when we already, many of the challenges we have discussed related to wireless networks, but today we will formalize the technical challenges or the research challenges involved in the success of wireless network. So when we will go and discuss the wireless communication challenges, here I have divided the wireless challenges into two parts. One I have associated with the radio communication, the radio challenges, network radio challenges, and the other one is associated with the devices, because the wireless devices is not the same device as the wired one. So there are certain challenges associated with the device also. Along with that, there are certain more technical challenges. Those also we'll discuss. And then finally, we will conclude this discussion with the reference model, the same TCP/IP model, but along with several other constraints involved while designing the protocols on each and every TCP/IP reference model. So we'll head straightway with the radio challenges. Here, as we all know, that the data rate and the error rate, the data rate is more in the wired network and the error rate is small. So when we want to put a wireless network in contrast and as a challenger to the wired network, there definitely the data rate must be higher, or at least must be somewhat compatible with the wired network, and the error rate must be small. But here, as you know, the medium is not wired. It's not a directed medium. It's undirected medium. The medium is air, and it is more prone to error. And because of the error rate is more, many of the time you have to resend it from the sender towards the destination. Even in the point-to-point communication, whenever you will start, many of the time, because of the more error rate, we have to retransmit for reliable communication. And because of retransmission, the overall throughput will be less, so your data rate would definitely be less. So that is one of the challenge, but somehow through research or through well thoughtful, insightful medium access protocol, we have to come up with those protocol or some modulation techniques. So primarily we have to work on the medium access layer as well as the modulation techniques which we will use, the antennas which we will use. So both at the data link layer and at the physical layer, they require a lot of insight, they require a lot of thoughts to work on higher data rate and with no errors. And mostly there is a compromise on the data rate because of the higher error rate. The error rates are more because the medium is undirected. The antenna technology is not that much sophisticated. And there are several other constraints as well. And the second one is the energy efficiency. This is related to device as well. So energy efficiency, because when you will transmit, you require energy. On which frequency will you work for transmission? And the device has a limited energy capacity. The device is running on a battery, and the battery comes with a constraint with respect to the energy. So definitely, what kind of a modulation technique we will use, how we will design our modulation technique, how we'll design the carrier frequencies, how we'll come up with the retransmission rate. All these things are the area of concern for efficiently utilizing the device constrained battery. That also goes, so it is more towards on the device side because the hardware is involved, but along with that, even on a software level, if you will see the medium access protocol which you will use, the modulation techniques which you will use, so all those things goes into the proper efficient utilization of the battery power. So that is also one of the constraint. Then, as we all know, the third one is the spectrum. The spectrum is limited. One is the technical issues with the spectrum, and another one is the political issue, as we know that because the spectrum is under the purview of regulatory authorities. So it is not in abundance. And the technical part is that whatever is available, how we can reuse that spectrum so that the same spectrums can be reused across different geographical areas so as to serve whole number of users. So, and that also involve the coverage area, because if your reusability increase with respect to the spectrums allocated to you, you can cover whole lot of area. That is also one of the issues where the research is going on, and it is also one of the challenges that how you can increase the cover area, how you can with the same allotted frequency bandwidth, how you can increase so the coverage base, how you can geographically expand yourself, and along with the geographical expansion, how you can include more number of clients, more number of users, how you can serve more number of users, whether there would be a clash, how will they uh, use the same frequencies, how that reusability would happen. Then along with that comes the reliability, and it is one of the challenging issues because whenever there would be a transmission from source to destination, then definitely the application requires reliability, and the reliability is one of the gray area concerning wireless network because of only because of the medium involved. The medium is undirected, and because of this air medium, there is well chances of losing the connections. So the fading of the signals. Because of that, reliability is one of the issue. So there must be the research is going on in figuring out the protocols at the transport layer, at the data link layer for ensuring reliability. At the data link layer, the reliability is being ensured from point to point, from one node to from one hop to the next hop. Whereas on the transport side, some tweak the TCP protocol as well as any of the protocol if you are using at the transport layer, definitely you have to ensure reliability with minimum retransmissions. We can ensure reliability through retransmission. That is the only mode through which reliability is ensured along with the data structures involved at the transport layer. But here the particular constraint is with respect to wireless network is that we want to ensure reliability through minimum retransmissions, because if the retransmissions would be more to ensure the reliability, then it will somewhere impact the data rate, the complete throughput, the overall throughput will be less. then comes, because to ensure mobility from one cell to the next cell, we have a concept called hands off. So through hands off, whenever you move from one location to the next location, and there you've been served through a different cell tower, then how that transition would be seamless. So the protocols are there: soft handoff, hard handoff, and in midway also there are several types of hands off involved. So the research, that is also one of the challenging and gray area, where to ensure mobility, because the mobility comes in three variant. Either you are walking, so it depends on the speed with which you are mobile, the user is mobile, either the pedestrian or the walking speed. And the second one is, so the speed is somewhere in middle, and another one is either you are moving in car and all. So based on your speed of mobility, which hands-off protocol would you use? So the research is going on. So it is not static in nature, the kind of a handoff which is going to happen with you. The device is same, but depending on the speed at which you are moving, what is the rate of your mobility, based on that, how dynamically the system, the infrastructure would come to a conclusion of type of a handoff, and even in the type of handoff, how much computing it requires to do that, what goes into that. So these are all the part of handoff strategies. So based on the handoff strategies, the mobility, uh, it means you are abstracted from the mobility. You will never come to a conclusion that you have moved from one location to the next location, because you will get the seamless connectivity. But behind the scene, the handoff plays an important role. So when handoff plays such an important role, it's a crucial part. So as a researcher, we want to make it more sophisticated, so that it will not be a burden on the cell towers, because they are also the part of the infrastructure, and we want to keep the infrastructure alive all the time. So if the number of hands off and the computation involved in the hands off would be more, then definitely it would be a constraint, it would be a sort of a burden on the base towers. So that is also one of the challenging area. And there in the handoff, there even your device also participate in that protocol concerning to handoff. So based on the device as well, because the devices are heterogeneous in nature, their power capacity is different, their computing capacity is different. So we require a kind of minimalistic architecture with respect to our hands off, so that it can work seamlessly with all the device types, all tower types. So that is one of the challenging issues regarding seamless interconnectivity. So this is all about the radio challenges involved. Now we will move to the next challenges, the device challenges. Obviously, the wireless network is for the devices which you can carry along with you, the pocket devices. So definitely, as we have seen also in our classes, in the last classes regarding evolution of the network, the size is getting smaller throughout all the evolution. So in 1G, if you will see those cordless devices, those are heavy devices. So, and the frequency on which they were working are also different. So based on the devices and the requirement concerning the generations involved, performance is one of the biggest issue. And the performance include both the computing performance, means with respect to the applications, what kind of an applications you can run on the device, because the device size is small, and that is one of the requirement which we have to adhere to. And the second thing is that the display area is very small in most of the wireless device. Most of the handhelding devices, the palm devices, the display area is small, and many of the applications which were there initially, most of the applications were for desktop, so they all were desktop applications. But now majority of the applications we want to move from desktop to palm top, or the devices which have the basic display area, very limited display area. So that is also one of the constraint, that how will you tweak your protocols at the application layer, so that the user will get the same performance. The user, with respect to analyze the performance of the application layer, would not find much difference with respect to the desktop application. So the performance is one of the challenge regarding the designing of the devices. And obviously, as you will move ahead along the generations, the requirement is that you have to minimize the size. So when you will minimize the size, when you will reduce the size, definitely you have to work with the semiconductor technology. So on the same chip, you have to bring several other resources, several other things, so as to you have to compact the chip size and include lot many resources on the same chip. So it will increase the complexity with respect to semiconductor involved. And as I have already discussed, this size, power, cost, and energy, this is also one of the constraint involved. The size must be small, the power consumption should be small, it should be energy efficient, and overall, if you will see, the cost should be such so that people can purchase it in bulk, and the technology can be used all across the masses, all across the globe. So while designing the devices, this is also one of the challenge, that not only it should be energy efficient, power efficient, size should be small, you have to somewhere cut the cost as well. So as a researcher, this challenge is always in front of you, and it asks you to actually somehow work around the technical situations, technical problem, so as to even reduce the cost. This is the health concern, because as we have seen over a period of time, as the generations evolve, the frequency increases on which the carrier frequency increases, on which the newer generation devices operate. And as we see today in the fifth generation devices, they will work on the millimeter waves. There the frequency is quite high. If the frequency is high, there is a technical concern associated with it, because uh, then, because if you will use more frequency, the technical aspect is, if the frequency is more, though you can carry more data, but you can carry that data for a shorter distance, then you require dense infrastructure to sustain and to provide the global interconnectivity. That is one constraint. And another constraint is with health, because we are not sure, there is no study so far which have concluded that it is safe for us to use the higher frequencies. Because if you will see this higher frequency, even for that matter, if you will see the wireless LAN, those operate on 2.4 megahertz, gigahertz, 2.4 gigahertz. And the same microwaves which are there in our homes, those are also operate on the same 2.4 megahertz. It is just the power difference. Here in case of microwave, it is somewhere around 800 megawatt, and here in case of our wireless devices, wireless LAN, it is less than 100. So that is just the power difference. So but we are still not sure that for how long it would then start impacting our internal organs, because microwave, if you will, if you will know, that is with a higher uh, power, it is dangerous for our internal organs. So that is one of the challenge. And along with this challenge, the cost is also one of the challenge with the higher frequencies, because then you require more infrastructure. And as we have seen over a period of time, multiple antennas are there to support more bandwidth, to support more data rate. So obviously when you will use different multiple antennas, so you will integrate different channel frequencies. So that radio integration is also one of the constraint issue, and those all things pertaining to the hardware involved, the semiconductor technology. How will you use, how will you design the antennas, how will you integrate the radio frequencies so as to support more bandwidth. And all these things are a sort of a tweak, because the frequency is limited. Within the same frequency, we have to provide at least the data rate compatible to the wired network. These are the device challenges. Now we'll go and move to some of the basic other challenges. The other challenges is that somehow the researcher has to come up with a measurement and measurement models for wireless indoor and outdoor channels. Because as you know, in the wireless indoor channel and outdoor channel, which frequencies will you use, which frequencies would be best to use. So still there is a lack in model. Maybe one part is the technical part, another part is the political part, the business oriented part, because frequencies are not yet decided. Some of the frequencies which have been allocated for 1G, still those are with the organizations uh, which purchased use them for their 1G communication. So still lot of problem is there in the resource allocation, and there is no still the research is going on in figuring out the model for wireless indoor and outdoor channels. Then comes this is the major part, because in the wireless scenario, as we have seen, for seamless connectivity you have the handoff procedure. But how will you then tweak your routing protocol, the IP protocol, for including the mobility, or for managing the mobility? How, which routing protocol will you use, which routing protocol will be the best? So all that is the part concerning research regarding routing at the network layer. Then comes so that we definitely require a kind of an architecture to connect the various wireless subnetworks together to the backbone wireless network. So in that situation, that architecture is not involved, and one constraint with the wireless network is there. It is heterogeneous in nature. In Europe, if you will go, the devices involved, the frequencies on which they operate is different from the frequencies in which in our India we operate. In Australia and New Zealand, if you will go, the frequencies are different. So there is a heterogeneity all across the domain. So in that situation, you require a kind of an architecture to connect various wireless subnetworks to the backbone wireless network, so that everything will work seamlessly. Then this is important, because as you know, the reference model, TCP IP model, from the application layer down to the physical layer. And I hope that you are aware about the working principle behind each and every layer. Firstly, the layered structure concept is only because in the layered structure, the underlying layer will provide certain services to the above layer. And as you know, the application layer, as I have already discussed about the application layer, most of the initial applications were desktop based, were for wired connection, but now you have to come up with the applications, the variant of the same applications which can work well with the constraint device. The device which has limited display area, the device which has limited computing capacity, the device which has limited memory capacity, the device which has limited wireless connectivity, means in terms of the bandwidth involved. So the resource hungry applications, how will you tweak? So in that way, you have to work all across the protocol stack. How will you tweak the protocols? How, whether the same protocol in all the situations will you use all across the protocol stack, or whether the several other variants of the same protocol to make those protocols simple, so that whenever any application you are running on the device having constrained resources, will switch over to those tweaked protocols on those layers. So a well integrated and adapted protocol stack for wireless network is a big requirement that extend across all the layers of the OSI model. So that is all about the challenges involved. In the next class, we'll start with um, our next module, signal and propagation.